My name is Wilfred de Vries. I'm a clinical physicist engineer at the radiotherapy department in Utrecht. I do have over 25 years of experience in radiotherapy. And as a physicist engineer, my focus is mainly on MR and MR-linac QA, as well linac QA, as MR QA, as patient QA. I like to stress out that I'm not an employee of Scandidos, nor do I have any vested financial interest in them. First of all, a short introduction for the hardware. The Delta4 Phantom Plus MR comes with a MR compatible trolley, and it as you can see in the picture on the right, I've placed it in our Unity machine over there. It comes, of course, with the Phantom. There is on the trolley there is a connection box, since within the magnetic field you can't have any electronics, so all the electronics are stored in that connection box, and with some cables you get a connection between the connection box and the Phantom. So the trolley has to be outside of the dotted line, which in the end Elekta will make on your floor in the MR room, which represent the 30 Gauss line. So it has to be outside of that dotted line. Furthermore, you need a connection, of course, with the connection box to the outside of the Faraday cage, and that is done by a LAN cable, which goes through the waveguide. The trolley and the Phantom are MR conditional, so you can use it in the MR room. It's certified to use over there. It is MR conditional since, like I said, you need to have the connection box outside of the trolley. For the power supply, that is of course not MR compatible, but still you can use it because the power supply comes with an extension cable, and you can put it into one of the wall sockets to apply the power to the connection box. But please use that extension cable because it comes not without a reason. Furthermore, the Phantom Plus MR, probably this is already information that you have seen on the website. It consists out of a PMMA cylindrical Phantom, consists of 1069 diodes distributed in a coronal and sagittal plane. It's 5mm spacing within the inner 6 by 6 centimeters, as you can see in the middle of the Phantom as depicted, and outside over there the spacing is 1 centimeter. The detector stability is very good. It's about 0.1% per kilogram that it is downgrading, but normally we see even less than 0.1%. Like said, it comes with a sagittal and a coronal board. The coronal board is actually consists of 2 plates. It's 2 wing boards. And the sagittal one, as you can see on the right side, it is a main board which goes through the 2 coronal wings. The software, the interface is very user-friendly. So if you start up the program, it looks like this. There is a patient database where you can store all your patient data in. It also shows you which kind of the plan name. It shows you the status, either it's measured or it's planned. You can see when you imported it, and it tells you on which radiation device it is it's planned for. Like Anders already mentioned, we do have 3 unities in Utrecht. We call them over here abbreviated U1, U2, or U3, and that's why you see those abbreviations in the radiation device names. When you have done a measurement, and later on in the presentation I will dig deeper into this, the interface looks like this. You can see actually over here that we measured 2 different fractions. So you get per fraction, you get a measurement. In the middle screen, you can see the two coronal wing boards, and in the right side, the sagittal board, where in gray there is represented the dose which comes to the diodes. Below that, you can see some histograms. And if we get a closer look into that after your measurement, you get the results. You get the results like dose deviation on the left side. You get it like a distance to agreement, and you get a gamma index. And that's instantly after that you finished your measurement, you get these results. Normally, we do our measurements with a 3% 3 millimeter criterion. As you can see in the upper part, there it says it's now the pass rate is 97.4% for dose deviation, which is within the 3% deviation, and so on and so on. Gamma index, you can see that it says 100% of my measured points is within a 3% 3 millimeter range. If you would say, oh yeah, but I don't like the 3% 3 millimeter, or for instance, you would like a 2% 5 millimeter or whatever combination, there is an option in the software which allows you to, as a user, to change over these values. Once you've done the measurement, and for instance, you've set the criteria at 3% 3 millimeter, you might ask yourself, hey, how good is my plan actually if I would set the criteria to 2% 2 millimeter? So the software guys from Scandidos created something clever they call the gamma index evaluation. And that's actually a right mouse click in the software, and actually then you get this table. And as you can see, if I go through 3% and I go upwards to the line where I see 3 millimeter, it tells me that the gamma pass rate is 100%. That's actually what we've seen in the histogram in the former slide. But if I would say, hey, what would be my gamma pass rate if I go for 2% 2 millimeter, then I go to 2%. I go upwards to the row where it says 2 millimeter, and then my gamma pass rate would be 99.2%. So I don't have to redo all the calculations or even the measurements. With this gamma index evaluation, I can easily see how good or how bad my plan would be with some other criteria. Something about the 3D dose reconstruction. The evaluation of those points that I just showed you is actually done on the measured points only. So that's only on the wing boards and on the main board. So that's the representation of the points in the histogram. But then you might ask yourself, yeah, but I do measure, or I want to have more information than only what I measured on the board. So therefore, there are a few options. You can either create some profiles with over those boards, and you see clearly a dose profile. In red, there is the planned dose. In the dotted, that's the measured points. You can also import your structure set from your Monaco TPS system, and from there on, you can evaluate your DVH parameters. I have to stress out that your structures are non-deformed imported from your TPS. So although your patient might have a completely other external contour than the Delta4 itself has, always be aware that if you import your structures, those are non-deformed imported. So it gives you an idea of where your structures would be within your measured points, and therefore you get the DVH information as well. Looking into that DVH graph, you see a dotted line which represents the measured dose, and you see a drawn line which is the planned dose. And as we've already seen in the histograms, this is almost a perfect plan, so your DVH information is also almost perfect. So In yellow, you see that the dotted line and the drawn line are almost on together because that's your bladder. In brown, it's your rectum, and in red, it's your PTV. Like said, it's still on the measured dots, but what you can do is you can get 3D information out of the Delta4 software. As you can see on the left side, you see a sagittal plane, a coronal plane, and a transversal plane with absolute dose values in there. And this is the reconstructed 3D dose. It reconstructs that 3D dose out of PDDs, which you give into the system. But once I get the absolute dose in there, then of course I know what my planned dose from the planning system in 3D would be. I can also calculate what my gamma index for all that 3D dose would be. Now, as you can see that the red contour depicts my PTV, and now I've set it at gamma index, you see that there is a red dotted area which represents an area with a gamma ratio larger than 1 within my PDV. But how bad is a small overdosage in your PDV? As long as it is within your targets, our opinion is that it is not that bad to have it. On the other hand, you could say if this red area would be in my bladder or my rectum, then I would have to rethink about delivering this plan. Something else clever we did is the so-called optimized phantom position. Normally you would place the phantom on the table and put it into the isocenter of the Unity machine. So you do it in the most appropriate way, so you don't have any positional errors. At least that's what you think. So then it's all set at 0, and then the outcome is like this. But if I would run the optimized phantom position, it looks for within the 3D dose to have the lowest gamma average with the highest gamma pass ratio. And if I run this tool, it will tell me that I have actually to shift my phantom by 0.2 of a millimeter to the left, 1 millimeter inside, and 0.2 millimeters downwards. And that's actually where the position is where my gamma average is the lowest and my gamma pass ratio is the highest. Like said, this plan that I just showed you, it was an almost perfect plan, so that's why these values are so tiny. If you run that tool, you see here on the lower left that it includes all those adaptations within the plan, and then of course your gamma or your dose deviation, for instance, goes from 94.0 to 94.3. Your gamma index was already 100%, but as you can see in the numbers, even your average and your average gamma is getting some lower. It was almost a perfect plan, so that's not that fair to say, hey, you got a perfect plan and you try to optimize it. So therefore, I took a plan that was less perfect, as so to say. In the upper part, you can see that my translations were all set at 0. Then I get a dose deviation of 78.8% and a gamma pass rate of 99.7, which is actually already good for a 3% 3 millimeter. But if I would shift my virtually shift my phantom by these numbers shown in the lower left corner, I get a pass rate, dose deviation pass rate of 95.8%. So it's even above 95% in dose deviation. And that's only due to the fact that I only shifted the phantom by, let's say, maximum a millimeter. Now probably the most important part, which is of your interest, why should you choose a Delta4? To answer this question, the first thing that you have to realize is which choices actually do you have. And if you look into nowadays market, you can choose between Delta4 plus MR. You have the R-Check, which comes probably with the installation team from Elekta. And there is the Octavius 4D Phantom. This is actually what you have in conventional at the moment. We chose Delta4 Phantom Plus MR because it's the only Phantom which does have the isocenter position at 14 centimeters above tabletop. And most likely the Elekta installation team already, or the physics team, told you that that is the nominal value for all Elekta Unity systems. So when together with the Scandidos guys in Utrecht, we developed this Phantom, I said one of the big things that you have to realize is that we need the isocenter of the Phantom at 14 centimeters above the tabletop. So that's always the coronal plane is at your isocenter height. And like I said, it's the only Phantom which does have the isocenter position in the center of the Phantom. Another big thing for choosing Delta4 is, do you measure within your high dose area? Because that's most likely the place where you want to measure. Normally, we as physicists or physicist engineers are not that interested in what's happening in your low dose area, but more likely interested in what will happen within your high dose area. So if you look into the R-Check, as you might know, the diodes are all on the wall of the Phantom, so it's not in the middle where most likely your high dose area is. Delta4 Phantom Plus does have that plus and is measuring in the high dose area, where in the end Octavius 4D, as you might know, is a rotating Phantom, which of course then also measures within the high dose area. So actually what we did was we created ourselves a table, and we looked into all those three Phantoms, and we said to ourselves, hey, what's the thing that we think is most important for having such a QA Phantom? And we came up with this whole list, which you now see on your screen. I like to say that this is done by the UMC Utrecht staff. And these are the topics that we think are important for a QA Phantom. It might well be that if you create a list yourself, you end up with the same like this, but you can add or add subjects to it or get subjects out of the list. Also, the scoring is done by hours. So yeah, it might well be that if you look into other Phantoms, you might score differently. And by doing so, it's just a matter of getting your pluses and minuses together. And if you do so, then in the end, the Delta4 MR will get out, or at least for our list, will get out as the most appropriate Phantom to use. The Octavius 4D MR I just mentioned is not on the market. So although we created the list, it is actually created on the Octavius 4D for conventional therapy. So there is no actually Octavius 4D on the market yet. So that's a no-go if you want to purchase a Phantom nowadays. So Delta4 at UMC Utrecht. Of course, we did some acceptance testing before we went clinical with the Phantom, and we looked into short-term reproducibility, dose linearity, dose rate linearity, dose per pulse, field size, angular dependency, and as you can see on the screen, all those measurements were within very acceptable ranges, and therefore we do have trust in the Delta4 Phantom Plus MR as a QA Phantom. I took some graphs out of the test that we did, and there you can see that we did it not only on the Unity machine, but also compared it to one of our agility machines. And therefore you can see that either if you use it on a Unity or on a agility conventional LINAC machine, it all behaves very well for all kinds of energies. Did we test other devices? That's often I get a question I get from people who say, yeah, you guys in Utrecht, you use Delta4 Phantom Plus MR, you developed it together with Scandidos, but did you really look into other devices? And the answer is yes, we did. Together with one of my colleagues, Annette Houweling, already in 2016, we wrote an article about the ArcCheck in a 1.5 Tesla field. Octavius is still a prototyping from PTW. Like I said, it's not on the market, but now sometimes they come to us with questions about how they should do things with Octavius MR. What the status is right now, I can't really tell you since I don't know. I will now follow the clinical workflow and go through with you through that and show you that it is pretty easy to work with the Delta4 Phantom Plus. This is one of our plans. Sorry, one of our prostate plans that we've planned in the Monaco TPS system for Unity. As you can see within the TPS, the couch is already modeled. There's the green structure on top of the patient, which represents the anterior coil, which comes on top of the patient. And it got a 7 fields IMT prostate plan for Unity. In the Monaco TPS, I can right click on the plan. I can say create a new QA plan. Then I pick the Delta4 out of it. I said, oh yeah, place my ISOC in the origin. And then it loads in the Delta4 Phantom. As you can see, the green structure of the anterior coil is already gone, since most likely when you do QA on the Phantom, you will not use an anterior coil, since you can't image the Delta4 Phantom itself. So there's no reason to have an anterior coil on top of on it when you're doing the measurements. Then you calculate the dose out into the Phantom, and as you can see, this prostate is laying a bit to the posterior side. So it's actually the high dose area is actually missing the isocenter itself. So if you got a coronal view out of it, there is no red area in there. But if you look into the sagittal plane, you can clearly see that there is a large area which covers my sagittal plane and where I can measure the high dose. Then I export it to a file location, which is just a folder on the network drive. It exports it into DICOM, and from there on I can in the Delta4 software, I can access that network folder and extract the data from there. As you can see, it's the prostate plan. It tells me it's a fraction with 7 beams. I just import the software, and this is all you can do from behind your desk. You don't need any machine time on the Unity to all this. You can all prepare this from behind your desk. And then actually you have to make your measurements. I like to stress out that the shown picture is different from the patient I've now show in this slide is different from the previous ones. So if you would say, hey, but now I got high dose in my coronal view, yeah, that's right. That's this is a different patient. But for the sake of presentation, I thought this represents it very well. So that's actually your clinical workflow. Like I said, the preparations can all be done from behind your desk, and actually you only need time to place your phantom on the table, do your measurement, which takes no longer than actually the radiation time which you radiate the patient with. So most likely it's up to 8 or 9 minutes per patient. Like Anders already mentioned, we already use the Delta4 Phantom Plus for quite a while. We got 3 unities, so actually we got quite some clinical results already. The treated tumor sites at Unity over here in Utrecht up to the 27th of January. That's when I created this list. The tumor sites we treated so far are like kidney, gynae, head and neck, liver, lung, lymph nodes, esophagus, pancreas, a lot of prostates, rectal cancers, and a category I call other ones. And as you can see, like said, the prostate is far the largest number of measurements we did. It's the number of measured plans, so it doesn't represent the numbers of patients treated. Since within the Monaco planning system, you plan with a template, and yeah, when we treated or we measured 25 patients with that template, we've seen that the data was very good, and the dose deviation and the gamma were all within the set criteria. That's when we said, okay, now we take it step by step, that we do now and then a measurement and not measure every fraction or every patient anymore. Only when there is actually need to, or when we think, oh yeah, let's do some measurements for some prostates. So the number presented over here does not represent the numbers of patients treated. That number of patients treated is actually far larger than the number over here. So actually we did 141 prostates measured, and as you can see, all the numbers are very well within the clinical tolerances. Same accounts for liver, for pancreas, for lung, rectal, esophagus, even lymph nodes, because the MR-linac, the Unity MR-linac, as you might know, is very well capable of imaging small lymph nodes, and therefore you can actually treat them. But of course, since it's a lymph node, the volume is very tiny. And then the question was, those tiny volumes, can we measure actually that with Delta4? And the answer is yes, you can. And as you can see, even for lymph nodes, all the numbers are well within the set clinical tolerances. I'm almost at the end of my presentation. Some other information. Of course, as you might already have seen or not, but then I would say let's go and have a look. Earlier on, I did a webinar for Scandidos about the whole development, acceptance, and first clinical results. It's on YouTube. Also on YouTube, there is a webinar about the validation of Delta4 Phantom Plus MR. And there they do a comparison between Delta4 Plus MR and the ArcCheck. And of course, there are a lot of publications out about all kinds of all those phantoms which are on the market actually. Also, they make a comparison, for instance, between gamma indexes for various commercial IMRT and VMAT QA systems. So I would say definitely go there and have a read for those. So in the end, Delta4 Phantom Plus MR, it's proven and stable diode technology. It gives reliable and quick results. You do not need any post-processing after you stop the measurements, so you get your results out of it. You get very good support from the vendor. It measures in the high dose area. It measures actually in the real ISO center of your Unity. And one big thing, which is an advantage of the Phantom Plus MR as well, you can use it both on MR-linac as well as on conventional Linacs. And that's for sure not for every Phantom the case, because I've heard, for instance, from PTW, like I said, they are looking into the Octavius, but they will develop two different Phantoms, one for the conventional, one for the MR-linac. So you can't use, you can't swap them around. But with the Delta4 Phantom Plus MR, you can. And from the clinical over here, I can say that we do use it in that way. So no matter if I have a plan for an agility or for an MR-linac, I always use my Delta4 Phantom Plus, the same Phantom for that. So therefore, I want to thank you for your attention. And I think we can now end the recording.